Leetcode question 24. Swap nodes in pairs. Given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the values in the list node. That is, only nodes themselves may be changed. In this first example, there are two pairs, the first pair and the second pair. So in this case, original linked list 1, 2, 3, 4 becomes 2, 1, 4, 3 after the swap. 1 swap with 2, and then 3 swap with 4. So the idea for solving it is first we need to have a dummy node. So that's a common technique for linked list. So dummy.next just points to the head node. Just points to the head node of the linked list. And then for this case, we need to have a previous pointer and then current pointer. So basically previous pointer points to the previous node, and then the current pointer points to the current node. So this current node is always the first node for each pair that we are going to swap. So the reason why we need the previous node is, so for example, when we move to the second pair, so we need, and then this node 3 becomes the current node. Let's suppose we already finished swapping the first pair, that we swap node 1 with node 2, and now we are moving to consider the second pair, and then the current points to the node 3. That is the first node in each pair. Current points to node 3, and then we during the swap, this node 3's previous node should point to the node 4 instead. So in that case, we need to know the current node's previous node. So that's why we need to keep track of it. That's why we are using a previous node. And then for the swap, let's go over the process. After we initialize the dummy, so we have the linked list. Let's use example 1. So dummy points to 1 and 2 and 3 and 4. For the first operation, basically we make dummy nodes point to the node 2 instead of node 1. So instead, after this operation, basically we have dummy points to node 2 and then node 3 and 4. The last two nodes now changed. And then we have the node 1 also points to node 2. So node 1.next is node 2. And then after this, let's do another operation. So in this operation, we point node 1 to node 1's next to node 3. So instead of pointing to node 2, so node 1 is pointing to node 3. So this is the link. These are the nodes after this operation. So basically, we got dummy 2, 3, 4, and then we get the list node 1 points to the node 3. So node 1.next is node 3. And then after that, we make another operation. That is node 2 the next node for node 2 is node 1 instead of node 3. So basically, node 2.next is node 1 instead of node 3. So in this case, we swap the first pair. And then we can move on to swap for the next pair. So this is the logic for solving this problem. Let's start coding. So we need to have a dummy node. So dummy is this node. And then the value is just 0. And then the next is just the head, because dummy.next is the head. And then we initialize previous and then the current. So for the previous node, it's just the dummy node. And then for the current node, it's just the head of the linked list. And then after initialization, since we need to consider for every pair in this linked list, so that's why we wrap this operation inside a while loop. So while current node, and then also current.next. That means, okay, we at least have two nodes that we can swap. If we only have one node, then there is no need to swap. Okay, in order to get for the first operation, that is dummy dot next. So dummy is our previous. So previous dot next is the node 2. So node 2 is current dot next. So here we need to know. So basically this current, using this example, this current, when we swap the first pair, this current is just the first node, and then this current dot next is just second node. And then for the first operation, we make dummy points to node 2 instead of node 1. So in that case, dummy.next is just the second node, that is current.next. And then since we want to do this, apply same logic for every pair, so basically this dummy is represented as the previous. We just use the first pair as an example to go through this logic. And then for the second operation, we need to change this first node's next node. So in that case, the first node is current, and then current next node is just the third node instead of the second node. So the third node is represented by current.next.next. So in this case, we make the first node next to be the third node. And then the third node is just, so remember, current is the first node, current.next is the second node, and then the third node is just current.next.next. And then after that, we change the next node of the second node from the node 3 to this node 2, to this node 1. Basically, we changed the second node's next node from the third node to the first node. So in that case, the second node right now is represented by previous.next.next. So basically here, previous.next is the second node. And then we change the next node. The reason why is basically right now, one thing we need to change is originally the second node is the current.next. But since we have already updated current.next, so in this case, the second node is just previous.next. The reason why is because we have already updated the current.next. So in this case, the current.next is no longer the second node. Instead, we have already swapped it to the right location. So that is the previous.next. So the next node of that is just previous.next.next. That should be the third node. And then we have not updated the third node yet. So in that case, the third node is still current.next.next. And then after that, let's update the previous and current node to move on to the next pair. So initially, previous is just a dummy node. And right now, when we are doing the update, we want to update the previous to be the second node. And the current to be the third node. So the second node after swap, the second node after swap already been changed. So that's why the second node is no longer current dot next, but it's current because we swap the uh, the nodes, the first node with the second node already swapped, and then the third node is just current dot next. So after that, we just return the head of this linked list. So we return dummy.next. Oh, my bad. This should be current.next because this current.next already been updated. So okay, let me see. So previous.next is current.next. This is second node, right? So so the head should be the second node. So that's what this does. And then the second node's next node should be the third node. So that's why current.next is current.next next. And then by this point, we already updated previous.next and the current.next. So in that case, we want to the second node. Oh, the second node should point to the second node. In this case, should point to the first node instead of the third node. So in that case, it should point to the current node. So this So I made a mistake here. So basically what we are trying to do this one is here, we are trying to go from this on line 28 and 29 to the linked list on line 34. So in that case, we just need to change the next node of the second node from node 3 to node 1. So in that case, the second node, because it's already been updated to the current location. So in that case, the second node is just represented by previous.next. So that's the second node. And then the second node's next node should point to the first node, the original first node. That is the current node. Okay, so this solution is accepted. So for this solution, as you can see, it's a little bit tricky. So you need to make sure the order for the swap is done correctly. So let's go over these three steps one more time. Okay, basically the first step, dummy points to the second node instead of the first node. So we update, so dummy.next, so that is previous.next, we update it to the second node. The second node right now is still represented by current.next. And then after that, we need to update the first node's next to the third node. So in that case, the first node right now is still represented by current because this current has not been updated yet. So we can still represent the first node by this current. So current.next, the next node for current node is just the third node. And then in this step, the second node's next node should be the first node instead of the third node. So that's why for the second node, it should be previous.next.next. That's the second node's next. So second node right now is represented by previous.next. And then its next node is just the originally the first node, that is the current node. So I know this solution is a little bit tricky, but you can see this is how it works. So another more, I would say a more intuitive way for writing this out is to use some temporary variables to store the node. So let me change the code. So in that case, we just change those three operations. So basically we are changing those three lines. So what are we are changing those three lines to? So basically first we need to actually store the node. So let's store the second node. The second node is just current.next. And then the third node, that is current.next.next. So in this swap, we store two temporary variables, second node and third node. So basically we assign the original second node and third node to those two variables. And then we will do the swap. So in this case, previous.next is just the second node. And then basically we make the originally second node now the head of this new linked list. And then after that, we update the second node's next node. We update the first node, the originally first node's next node, to be the third node. So in that case, we can update. So original first node, current.next, is just the third node. And then for the third node, so after that, basically the second node's next node should be the first node. So in that case, second node.next. Actually, let me use this one. So still previous.next.next. It's just the first node. That's the current node. Okay, so this one remain unchanged. So let me just run this one. Okay, this solution is accepted. So this solution is accepted, but why we need those two dummy variables? Why we need those two variables, second node and third node? So the beauty of it is, okay, if I'm writing it this way, you can now tell the difference. But what I can do right now is I can actually swap the sequence. So the order of doing the swap. Let's say here for this one, let me just move right after here. So in this case, let me run the solution. So now it's still accepted. So in this case, the point I want to illustrate is that, okay, if we are using some temporary variable, second node and third node, the order we are performing those swap operations can be changed. So basically, originally this line is the third operation, but now we swap it to be the second operation. We can do this with the help of the temporary variable, but we cannot do this if we do not store the second node and then the third node with the variable second node and third node.